This video goes over the power rules that we need to use when we're working with exponents. So first off, some of the components. This whole thing is called a power. The A, or the number that's there, is called the base. And the M, or the little number, is called the exponent. So in the example, 2 cubed is the power, 2 is the base, and 3 is the exponent. So when we're multiplying powers, the rule is for powers with the same base, keep the base, and add the exponents. So, for example, we have 2 cubed times 2 squared. The base is the same. So to simplify, I can keep the base and add the exponents. 3 plus 2. Another example here, our base is the same, 2 again. And now we can add the exponents. 4 plus 2 is 6. We can also do it in general, even if the base is a variable. So here the base is the same. So we keep the base and add the exponents. 6 plus 2 equals 8. Our last example with a W, the base is the same, and we're going to add the exponents. Our second rule is when we're dividing powers. So again, for powers with the same base, we're going to keep the base and subtract the exponents. So here we have 3 to the 4 divided by 3 to the 2. In this case, the base is the same, 3, and we're going to subtract the exponents. 4 minus 2 is 2. In example B, we have 2 to the 7 divided by 2 to the 2. Our base is the same, so we can subtract the exponents. We can do the same thing just as above, even if we have variables as the base. Here we have W to the 4 divided by W to the 2. Our base is the same, so we can keep the base and subtract the exponents. 4 minus 2 is 2. Our last example here, this is a bit of an extension. Here we've got negative exponents. Our base is still the same, and then we're still going to subtract the exponents. We've got minus 5, take away minus 2. Using our integer rules, we have a double sign, so we really have x to the minus 5 plus 2, which is going to leave us with x to the minus 3. This is a bit of an extension just to show you something a little bit extra. The last rule that you should be familiar with is evaluating a power of a power. So that would be something that looks like this. When you're evaluating a power of a power, you're going to multiply the exponents. So in general, that's going to look like this. So let's evaluate the following expression here. X squared to the exponent 3. So what we're going to do is keep the base, and we're going to multiply those exponents to give us x to the 6. Now let's look at some examples where we're going to simplify, so write as one exponent, and then evaluate. So here we have 7 cubed times 7 squared. Our base is the same, so we're going to add the exponents, and then we're going to evaluate. So 7 to the exponent 5 gives us 16,807. Our next example is a power of a power. So we have 2 cubed raised to the exponent 2. We're going to keep the base the same, multiply the exponents, and then we can evaluate. 2 to the 6 is 64. Our third example has some integers. Here we've got minus 5, really to the exponent 1, even though there's nothing written down there. So that means that our base is the same, so we can keep the base. Because we're multiplying, we're going to add the exponents. So 1 plus 2 is 3, and now we can evaluate minus 5 cubed, the same as minus 5 times minus 5 times minus 5. Odd number of negative signs, so our answer is a negative, and we get 125. Our final example here is dealing with division. So we have 2 to the 5 divided by 2 cubed. So we can keep the base, subtract the exponents, and now we can evaluate that easily. Those are some examples of the power rules that you need to be familiar with to help you to evaluate expressions.